Hello students. Today we're talking mass storage technologies. Now we'll be covering this in chapter 8 and 9. This first lecture is fairly short and to the point. It'll cover a lot of legacy products, and then we're going to go into the future. Now to start off with mass storage, we're going to look at how hard drives work, and they're changing rapidly. I outlived floppy drives, and I think I just outlived hard drives. We'll look at mass storage interfaces, where we're going to look at RAID, and we're also going to look at the installation of hard drives. Now, a traditional hard drive is a bunch of individual disks. These disks are in a package that's hermetically sealed. These platters or disks are aluminum coated with a magnetic medium, usually ferric oxide, and they have these tiny little just basically pieces of metal, and you can either magnetize or demagnetize them with a small magnet. This electromagnet is at the end of a very, very small armature. The hard disk drives are referred to as magnetic hard drives or platter-based, and here's a good example of them. So if you're looking at this, let's see. Let me get my laser pointer out. Right here is a little armature. You can see that. Here's the disc. The disc spins. The armature goes back and forth, and it covers the entire disc. It can detect whether there's a magnet or not magnet on a little track within this. Brute force simple. Now the hard drives spin at different speeds. We talked earlier that it spins. The faster it spins, the faster you can read it. And you're looking at revolutions per minute. The older ones ran at 3,600. Common speeds, as this thing's winding down, is 54 and 7,200. At 10 and 15,000 RPMs, it has a problem with heat and performance. And it can also reduce the lifespan. In the most recent hard drives that are platter-based, I noticed more and more drive bays have fans just for the hard drive. Here we go. So here's the bay, here's the fan. Now these are being replaced with solid-state drives, just like a jump drive, same technology. And what they're doing is, since there are transistors, there are no moving parts. It was more expensive than the platter drives, but the cost comes down over time of all digital products, and I think they're going to pass them by. The solid state technology is used everywhere now. We're talking phones, cameras, USB drives, you name it, it's probably got a little solid state drive in it. Now the solid state form factors are typically 2.5 inches, and they have some other variations, such as the M-SATA and the M.2. They have a really high-speed read-write cycle. They cost more, but you get a better performance, particularly if you have an older device. You put in a new solid-state drive, it may seem awfully fast. Now, Windows can support hybrid drives. Here, they've got the flash memory and spinning platters together. This isn't unusual. When you have a new technology, a lot of times you'll have it combined with old technology to try to get through the cost curve. And Apple computers can use a fusion drive. It's similar to this hybrid drive. Now, connecting mass storage devices. In the old days, we used this ATA, and it was integrated drive electronics, and the parallel ATA had a 40 or 80 pin wire cable. Maximum length was about 18 inches. The serial ATA, which sent data in a serial wire configuration, which only had 7 wires, turned out to be about 40 times as fast. The largest ATA allows very large hard drives, up to 144 petabytes, and you can have up to 2 PATA hard drives connected to a single ATA controller. And that was the nature of it in the old days. And they had some additional stuff, self-monitoring analysis. Now, the SATA or SATA are improvements over the PA or PATA. The point-to-point connection between SATA and device is on the host bus adapter. Narrower cables, they can be longer, a meter versus 18 inches, hot swappable, and there is no drive limit. Because of that, we've been able to do things such as RAID, theoretically 30 times as fast as the PATA, and that's just the start. They're continually faster. The SATA Express, okay, ties cable drives directly in the PCI Express bus in the motherboard. With a lack of overhead, it makes it even faster. It requires the motherboard to support and take advantage of the super fast speeds. Now, you also can have an eSATA. Here, extends the SATA bus to external devices up to 2 meters in length, and it's a full bus speed. So you can have external drive enclosures that are just like having it internal. So it makes it a lot easier to upgrade and store data. The current version of Windows supports the A8CI controller interface. Really decent. It supports hot swapping. And if it's not enabled, you have to add a new hardware wizard. It uses NCQ, native command querying, for optimizing, and gives you the best read-write speeds. It's best to enable this in CMOS before installing operating systems. You say, well, what's that? Well, you generally have 3 options. The EDIE, am I saying it right? Or AHCI or RAID. Now, NVMe, this is the new boy on the block, the bad guy. In order for this to work, okay, has to make the SSD circuitry appear to be like a spinning drive. Again, they're having to use that instead of the newer technologies. The NVMe supports communications directly between the PCIe bus lane, and these are really interesting. I mount these drives, which look like a memory stick, horizontally right on top of the motherboard. Darndest thing, and they are blazing fast. Now, data is the most critical part of the PC, and there's several ways to protect it. So we're putting everything on computers, right? So you want to make sure that it's saved if something goes wrong. One of the first tools was disk mirroring. You have 2 disks. The read and write is the same to both drives. If you lose one, then you simply take it out, put in a new one, automatically writes the data from disk 1 to disk 2, and you have 2 drives again. Disk duplexing, where you have a separate controller for each. Striping, which is pretty popular, and then striping with parity. Adds parity, where you can use that to rebuild a computer disk. So here's mirror drives, duplexing. Notice we got 2 controllers, and then disk striping. Here, just like with the mirroring, we have multiple connections to the controller. Now, the RAID, which stands for Redundant Array of Independent Disks, is the tool that we use. RAID 0 provides striping, no redundancy, but it improves your speed because you have 2 cables going in and out. RAID 1, disk mirroring, requires at least 2 drives. So you have to have 2 drives to get the same amount that you get out of 1 drive. The beauty of this is, though, if you lose one, you don't lose both. Then RAID 5, pretty popular with network and other systems. And here it distributes data with parity information across the drives. It's the fastest way to provide redundancy. RAID 6 is disk striping with extra parity. Then RAID 10, the stripe of mirrors, a pair of mirror disks and another pair of mirror disks. So basically, we're doing striping with mirrors, so if you lose one, you've got multiple backups. The cool thing about this is it's becoming part of almost every computer, and we'll talk about that later. RAID 0 plus 1 starts with a RAID 0, stripes arrays, then mirrors the other 2 arrays. So RAID, if you've ever played with this, there are thousands of ways of doing it. You can get specialized RAID controller cards that can hold up to 15 drives, or a lot of motherboards now are built with RAID in mind. They'll have 6, 8 SATA connectors on the motherboard just set up for RAID. So you can do that with a server, so to speak. The software RAID, now this is interesting. It is there. I don't have to install the operating system. I simply plug in a couple of hard drives, and all of a sudden, I have the ability to set up a RAID 0 or RAID 1, and this is usually run by software that comes with Windows 10. Then a hardware RAID requires an intelligent controller, and you have a lot of chips on board that will do that. Once you've set this up, and do that in your BIOS, and we'll have a lab just on this, it's invisible to the operating system. It sees nothing new. It's just a different way of installing it. So you'll have multiple hard drives, but if I lose one, then I can put another one in, and it will basically rebuild it. The Windows doesn't know or care, and it replaces a bad drive without disturbing the operating system. There we go. Now we're going to spend a lot of time in the device manager and disk management when we're setting up RAID. So this is showing me all the different drives, and here I can actually build the software RAID if I want. It's a little bit different with RAID on BIOS. So things that we have to do: choose your drive. I look for the best bang for the buck, and over time they get cheaper, better, more powerful, but I always like to have plenty of hard disk space. If I'm using 70% of my hard disk, I'm going to see a decrease in performance. Okay, make sure you have room for them. That's the nice thing about the new solid state drives. Take up less room. Now with the old PPT, you basically could have two drives, a master and a slave. Bad connotation, but there it was. And you would have to put some pins in the back of the hard drives, basically dip pins to make sure they work properly. Jumpers, if you will. There you go. And here's how the settings were. They would tell you where to put the jumpers. Pretty simple. Then the power cable. It's pretty interesting. For the SATA drives, now this is the power cable, and this is the data cable. In the old days, the data cable was thick and the power cable was thin. There are no jumpers. It's all done through the CMOS. And then connecting this, just like anything else, I have to have power, I have to have data. Then, do I have the appropriate drivers, firmware, everything is backed up. Pretty simple, pretty straightforward. And when I'm setting up a RAID, I have to go into the BIOS. I just mentioned it, make sure that I have RAID enabled, and then I'm able to run through the little installation. It's a little bit different, but it's not hard. There we go. Let's see. Yep, installing drivers. Cool. And then boot order. Important. You need to boot when you're assembling your computer from your optical drive. Once you have changed that to hard drive after you've installed, it should stay there. In a lot of the motherboards, you're going to have to enable your AHCI. Okay. The other things, power. Remember, each one of the hard drives is going to take power. So if I've got 15 hard drives, mama, I've got to make sure that my power configurations are set up for that. I need to set them up properly, and I need the CMOS to recognize them. We're going to do all of this in labs. If a device is not recognized, go through the steps, see what's wrong, check the connection, check the hard drive, make sure the CMOS recognizes it. Generally, that will